Welcome to the GeoMethod channel. Today, we are solving another interesting geometry problem. Here is today's challenge. Can you find the perimeter of ABC from areas 1 and 4? Take a moment to study the figure. Then, let us uncover the key geometric ideas that make the solution click. Here is the blue triangle ABC with a right angle at B. The altitude BD meets the hypotenuse segment AC at D. We need to find the perimeter of triangle ABC. The perimeter is simply the sum of the three sides, segment AB plus segment B, C plus segment CA. So the whole job is to pin down those three lengths, and we will get every one of them from the two areas we are given. The altitude splits the big triangle into two smaller ones. Look first at the green region. Triangle ABD. Its area is given as 1 square centimeter. The second piece is the purple region, triangle BDC. Its area is given as 4 square centimeters. These two numbers, 1 and 4, will unlock every length in the picture. Notice that both small triangles use bases segment AD and segment DC on the same line AC, and both reach the point B through the same altitude BD. So the two pieces share one common height. The area of any triangle is 1/2 its base times its height. For our two pieces, the height is the same segment BD. So their areas differ only through their bases, segment AD and segment DC. Here's the first insight. Triangles ABD and BDC share the same altitude BD to line AC, so their area ratio is exactly the ratio of their bases segment AD and segment DC. The given areas 1 and 4 therefore determine the split of the hypotenuse without revealing any side length yet. Now substitute the given areas. 1/4 equals segment AD over segment DC. So the foot D cuts the hypotenuse in the ratio 1:4. To carry that ratio cleanly, let segment AD equal K and let segment DC equal 4K. Then the 1:4 split is built in automatically, and a single unknown K now controls every length. The hypotenuse segment AC is just the two pieces joined together, segment AD plus segment DC. That is K plus 4K, which gives segment AC equal to 5K. We will need this length in the area equation shortly. Here is the second insight. In a right triangle, the altitude from the right angle to the hypotenuse is the geometric mean of the two hypotenuse pieces. Thus, segment BD squared equals segment AD times segment DC, linking the red altitude directly to the 1:4 split before we solve the scale. Substitute our lengths into that rule. Segment AD times segment DC is K times 4K, which is 4K squared. So segment BD squared equals 4K squared. Take the positive square root, since a length can never be negative. Segment BD equals 2K. Now, every segment in the picture is written in terms of the single unknown K. Now return to the green triangle, whose area is 1. Its base segment AD is K, and its height segment BD is 2K. So 1 equals 1/2 times K times 2K. The right side is simply K squared. Because K is a length, take the positive root. The scale factor is exactly 1. Feed K equals 1 back into every length. Segment AD is 1, segment DC is 4, the altitude BD is 2, and the hypotenuse segment AC is 5. Only the two legs segment AB and segment BC are left to find. The green triangle ABD has a right angle at D, with leg segment AD equal 1 and segment BD equal 2. By the Pythagorean theorem, segment AB squared is 1 plus 4, so segment AB is the square root of 5. The purple triangle BDC also has a right angle at D, with leg segment DC equal 4 and segment BD equal 2. So segment BC squared is 16 plus 4, which is 20, and segment BC is 2 square root of 5. Now add the three sides. The perimeter is segment AB plus segment BC plus segment AC, which is the square root of 5 plus 2 square root of 5 plus 5. The first two terms are like radicals. 1 square root of 5 plus 2 square root of 5 is 3 square root of 5. Adding the 5 from the hypotenuse gives 5 plus 3 square root of 5. Therefore, the perimeter of triangle ABC is 5 plus 3 square root of 5. So the final answer is 5 plus 3, the square root of 5. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.